In this video, we're going to take a look at a really popular question called invert binary search tree, in which we are asked to invert or inverse a binary search tree. What that basically means is that we want to swap the left and right children of every node. So for any given parent node, the left child becomes the right child and the right child becomes the left child. And a common thing that people may say is, when would we ever want to do something like this? And the answer is never. It's just a common interview question, so I feel I'm kind of obligated to at least show you the way that this is done and explain a way how it generally works so that if you encounter it in an interview or something like that, you are prepared. The idea of the invert is not really too complicated. It follows a lot of the similar patterns to basically swapping elements inside of any other algorithm. Just that we're doing it recursively, which makes it a little bit more complicated to kind of wrap your head around. But we're going to set this up the same way that we would any other recursive function that we've seen so far in this course. And then basically what I'm going to do is I'm going to iterate through my tree. And my return is going to be, if the current value is basically none, right, then we're going to return. So if not current, then we return. If we have a node, what we want to do is we want to swap its left and right children, right? So basically, I'm going to track what's currently at the left. I'm going to store it inside of this temp variable, right? Then what I'm going to do is I'm going to set current.left equal to current.right. That effectively switches the left and right. And then in order to update the right properly, we set it equal to temp, which is where we stored the previous left, right? So you can see that this is really just the same as any other swap. We're just swapping the left and right children of the node that we're currently at. And then what do we do from here? Well, we recursively iterate, right? We want to then do the exact same thing with what's on the left-hand side, right? And we want to do the exact same thing with what's on the right-hand side. So really, when you break this down based on the actual components for this, it's not really too complicated. You'll see that a lot of tree things really follow these same sort of patterns, right? This iterates the tree. This does what we want to do. In this case, swaps the different elements with each other. And that's really all there is to it, right? Time complexity for this is O(n), where n is going to be the number of nodes in the tree. Since we have to touch every single node inside of the tree, that's generally going to be our time complexity. And I could show you this easiest with the level order traversal. So I'm going to invert my tree, and then we'll do another level order traversal, okay? So basically we're going to do two level order traversals, and just to make it really clear, I'll go ahead and put a dividing line between these so that you can more easily see. And now let's just go ahead and actually run this, and we'll take a look at what actually happens here, right? So we'll run chapter 7 node.py. And what you'll see here is that on the first traversal, basically the ordering is flipped in the second, right? So do you see that it goes 50, 30, 70, and the inverse goes 50, 70, 30. So those two switch spaces with each other. And then what happens is the switching basically continues on. So as we move through the different levels, right, the level used to be 20, 40, 60, 100. It's now flipped, 100, 60, 40, 20. So you see that it's now reversed of what it originally was. So that's the idea of inverting a binary search tree. Like I said, probably not something you're ever going to do in an actual program, but it's something you may need to do in an interview, so that gives you the explanation of how it's done and the basic idea around the actual code for it. So thanks so much for watching. I'll see you in the next video.